Start. So I'm recording as well. Let's hope this recording stuff works. So I don't know if you've seen this before. Saki made it, I think, a couple of days ago. So let's put it full screen. There. So what you've been working on so far as I understand it, is the stuff on the client, which is all this stuff over here in the left square, the HTML, CSS, the JavaScript that runs on the phone or on the browser or wherever it is, and then sends requests to your Node.js server, where you request data or store data or whatever it is you do on the Node server. So that's the JavaScript running on the server side. It's not running in the user's browser so far. And what you've been doing so far, when you want to store data, as far as I know, you just saved it in JSON files, right? So you saved like cars.json or contacts.json or whatever. So just a very simple way of storing data in a file. And what you normally do if you build a web app or an app in general is you store it in some sort of database. Oh shit. Coffee. Okay. So yeah, if you build an app or a web app or a desktop app, whatever it is, usually if there's some sort of server-side storing of data involved, you store data in a database. And it can be a lot of different types of databases, SQL, NoSQL, graph databases, a lot of different types of databases. What we're going to be working on is SQL databases, which is short for Structured Query Language. Some people say SQL. I like saying SQL because it makes it more clear what I'm talking about. And it's a way to store and retrieve data very efficiently. So imagine you want to store like 10 cars in a JSON file. That's fine, you can do that. But if you want to store 100 million cars in a JSON file, it very quickly becomes extremely large and becomes hard to load and edit. So a database is very good and very efficient at storing data. And when you want to ask it questions about the data you have stored, it can also be very, very fast. So if you have a database with 100 million cars in it, you can say, I want to get all the red cars. And it's going to happen in a couple of milliseconds, even if you have to look through 100 million rows in a database, 100 million entries. And there's a lot of different types of SQL database called DBMS, I think it's called, database management systems. So maybe you've heard about Microsoft SQL, MS SQL, or Postgres SQL, or Oracle, which is a very old and very expensive version of an SQL database. But they're all basically following the same, it's the same type of database. They have differences individually. So one database, for example, MySQL and Postgres is open source and free, and you can use it wherever you want. Whereas Oracle, you have to pay for it. It costs you $1 million if you want to, get one installed or something like that. But they all follow the same standard language, which is the SQL standard, and some of them have different features on top of them. But I'd say 90% of the language is the same. So if you know how to work on a MySQL server and query for data and store data, you can extremely fast learn how to do it on a Microsoft SQL server or Postgres. But we're focusing on MySQL because it's easy to get started with, and it's widely used, and it's free, so we don't have to pay for it. Let's get back to So did anyone see all the videos in the playlist before we started?
I've seen the first one, but the other one I haven't had access.
Okay. Well, after, you might want to watch all these videos. There's a playlist here after the classes, so during the week or something. They say a lot of the same stuff that we're going to say today, but they're pretty good at getting an introduction to databases. Just say if you want to say anything.
Yeah, we can start, I guess, with more. So, go ahead. Okay, so we can go into the databases actually. So Martin was talking about the database management system. So yeah, like MySQL or PostgreSQL, whatever. But like you use one of them and to store your data. You store your data in a database. And a database at the end of the day is basically a set of tables, and they have relations between themselves. Like there's the name like relational database because there's relations between the tables in the data. And like each table will have, like for instance the cars example, each table will have a column for the name of the car owner, for instance, the car brand, and that's the person bought, and maybe the date when they bought the car, and whatever information you want to have in there. So each column will tell you something. We call them fields, I think, officially, or you can just call column. And then each row is just one data entry. So for instance, Rohit bought a Mazda. So all information about is buying a Mazda is on one row. And then Martin bought a Porsche, and each the next row is about that one. About Martin buying a Porsche. So yeah, that's basically.
You can visualize it if you have like a spreadsheet thing.
Yeah, like.
I guess you all used Excel or some sort of spreadsheet software or whatever. So let's imagine that you have a database of cars and people who bought the cars, something like that. So this is a very like buyers. Cars. So just say you have an ID of the car. I don't know if you can see this. Maybe I have to. I'll assume in this thing.
Control plus method.
Yeah, no, that doesn't work. There. I think you can see it a bit better now, right? I hope so. Brand, year, price, whatever. One. That's a cheap car. So we have a database with cars in them. We have 2 cars. Let's say we have 2 buyers as well. So we have Bob and Alice. So this is like the mental representation of a database. So you have let's say, so you have a table full of cars, or full of 2 cars. They each have a unique ID that is unique to the car. In this case, the first row has the ID 1, 2, 3, 4. Usually you'll be using integers or numbers as IDs. They have properties like you're used to in JavaScript. It's columns or fields in the database. They have brand, year, price, and in the buyer table we have the name of the buyer, the phone number, and the email. Oh, I clicked on the email somewhere. And the ID here is unique to this table as well. So the ID column is always unique to the table that you find them in. So the ID 1 here represents the Bob guy. Whereas the ID 1 here in the cars represents the Mercedes car. And here we have what's called a foreign key. So we have relations between the data. So we have, let's say Bob bought the Mercedes and Alice bought the Porsche. So this table now is a list of cars that have been sold, and the buyer refers to another table. So in this case it would be another spreadsheet, but it's still the same as in the database. So we see that, the buyer ID is number 1 for the Mercedes, and that would be, so Bob bought the Mercedes at the price listed in the table. And you can have never-ending amount of relations between tables. So you could have, if you wanted, for example, that you can buy more than 1 car, you can add another table that indicates who bought what car. So then Bob can buy both cars, the 3 or 4 cars. You can add different. You can imagine a car sales shop that do repairs as well. So you would list when someone bought a car, and then when they come in for repairs, you can see when did they buy the car, how old is it, all this stuff, all stored in the database. So you can imagine most apps or web apps have some sort of database behind them where all this data is stored. So in its full extent, like something like Facebook or Twitter as well, they have a database behind them. So all the stuff that you post on Twitter, all the messages you send, ends up in a database somewhere. It's a very fancy, advanced, fast version of a database, and they do a lot of stuff to it, but in the end it's just a database that stores everything. Let's see. There we go. Yeah, so the stuff I showed you in the spreadsheet here, the schema, is basically the definition of the tables. So one of the good things about SQL databases is if you define a table, you define them as having a set of rules. So you say the first column has to be a number and it has to be unique. The second column is a string. It doesn't have to be unique because you can have people with the same name. The phone is a phone number, and let's say you want it to be unique because you don't want people to reuse phone numbers across, but you could have, if you have a married couple who buy a car each, they could have the same phone number, but yeah. Email, you'd want to be unique. So you can define all these rules for the database tables, and then if you try to break the rules, you're going to get an error. So you can't break the rules of the SQL database. So if you say that this table refers to this table, or this field is an integer, or this is a string, and this has to be there, then you're 100% guaranteed that if you ask for data from the database, it's going to be there. If the rules say it's going to be there, otherwise the database doesn't work. Yeah.
Does it mean that certain permission have to give to the main table?
Yeah, kind of, yeah. So when you create the table, you specify what the different columns can contain. Yeah. So you could, for example, say that in the car table, let's say this buyer ID column, you say, well, it has to have a foreign key, which is just a way of saying it has to point to the buyer table, but it doesn't necessarily have to be filled in. So it can either have a number or it can be empty. But you can't write like a test. You can't write a string or like something in there that doesn't exist. So if I tried to put in, let's say the number, let's just say I tried to put in the number 3, and that buyer doesn't exist, then you're not allowed to do that. You're going to get an error back from the database saying I can't do that because the buyer with ID 3 doesn't exist. So it's a way of ensuring that the data that you store is consistent with the rules that you set for the database. And also, if you, let's say, someone else makes the database for you, then you can be sure that if you read the rules of the database or the specification of the database, you're 100% sure that what you get back is what you expect, because that's how the database is defined.
And just a quick question that might be a bit advanced, but why do you think that Martin decided to make a table for the buyers and a table for the cars separately? Like in the beginning I was saying, oh, you can have like the buyer name in one column and then the car you bought and then when you bought the car, all in the same table. Martin decided to make two.
It's like because we have two primary keys, two unique keys, ID for car, ID for buyer.
No, the primary key is one, but the way of you link it to two tables like this is making shortcut to going to write, I think, not there.
I think one of the tables is to specifically to store the information of the buyer, which the client can make reference to any point in time. Then the other table is for maybe the dealership to have access to immediately.
That's one reason.
Yeah, that's part of the reason here.
But what if the same person buys two cars and you only have one table? Like the thing is, if the same person buys two cars and you have just one table for everything, you'll have like repeated information in the database. And this way you just have like one entry for the buyer in the buyer table, and then you have like as many cars as you bought in the other table. And as you said, also, it's if you only want the buyer's information, it's faster. You don't need to get all the other stuff.
Yeah. Because I added a third car, the Fiat something, and we have a so they point to the same person. These two, so 1 and 1 points to Bob. Whatever. Yeah, Bob. So he bought 2 cars instead of 1. So that's what she just.
Yeah, and if it was in the same table, like the phone number would be duplicated.
Yeah.
When you want to update the table, that might cause problems.
But also, sort of what he said is like you could save the buyer on their own, and you don't need the card information to wait for save. Like if you have validation that this needs to be entered, then you wouldn't be able to save unless you have all the information at once.
Yeah.
Yeah, we used to have like a whiteboard, which I used last time for the ER diagrams because that was easier. But I don't
But I have
know.
an ER diagram.
Oh, you have one? Okay.
Yeah.
You can just take over.
So let me try to cast and see if it
Yeah.
works. Yay! Awesome. I just need to find the diagram. So we'll be working with